Tonight, if the sky is clear, look up. Somewhere in that darkness, closer than you think, there is another world. It may be rocky, it may have a surface, and under the right conditions, it may have water. A planet roughly the size of our own, circling the closest star beyond the sun. It is not science fiction. We have found it. We know its name. We know how long its year lasts. It sits just 4 light years from where you are sitting right now. For most of human history, we had no idea whether other planets existed at all. We could see stars, but we could not see worlds. Then, in 1995, astronomers confirmed the first planet orbiting another sun-like star. It changed everything, because if there was one, there could be more. Today, we have confirmed more than 6,000 of them. Gas giants, frozen wanderers, molten hellscapes, worlds of every kind. But here is the strange part. The most important ones may not be the most exotic. They may simply be the ones nearest to us, because those are the only worlds we could ever hope to study closely, the only worlds we might ever reach. So tonight, we are not traveling to the edge of the universe. We are going next door. Proxima b, the nearest world, the closest star to our sun. It is called Proxima Centauri, a small, dim red dwarf, 4.2 light-years away. It is so faint that you cannot see it with the naked eye, even though it is our nearest neighbor. In 2016, astronomers announced something remarkable. Proxima Centauri has a planet. They named it Proxima b. It is likely a rocky world, with a minimum mass slightly above Earth's, and it orbits inside what scientists call the habitable zone. That is the narrow band around a star where temperatures could allow liquid water to exist on the surface. Not too hot, not too cold. Think about what that means. The very first star outside our solar system, the closest one there is, and it has an Earth-sized planet sitting in exactly the right place for water. Out of all the billions of stars in our galaxy, the nearest one happens to hold a world where oceans could exist. Astronomers found it not by seeing it, but by feeling it. As Proxima b orbits, its gravity tugs gently on its star, pulling it back and forth by a few meters per second. A wobble smaller than the speed of a person walking. Across 4 light-years of empty space, we detected that. It seemed almost too lucky, and it was. The problem with red dwarfs, because Proxima b does not orbit a star like ours. It orbits a red dwarf, and red dwarfs are difficult neighbors. They are small and cool, so their habitable zone sits extremely close in. Proxima b circles its star at about 1/20th of the distance between Earth and the Sun. A full year there lasts only 11 days. Orbiting that close has consequences. The planet is very likely tidally locked. One face turned permanently toward its star, the other in endless night. On one side, eternal day. On the other, eternal darkness. There would be no sunrise, no sunset, no seasons, no years as we understand them. The star would simply hang in the same place in the sky, forever, never moving. And on the far side, an unbroken night that has lasted billions of years. If life exists there at all, it may cling to the thin twilight band between them. A ring of permanent dusk, wrapped around the entire world. But there is a far greater danger. Red dwarfs are violent. Proxima Centauri has a powerful magnetic field, and it lashes out. It fires enormous flares of radiation, far more energetic, relative to its size, than anything our sun produces. Some are so intense scientists call them super flares. Our own sun has tantrums too. But Earth sits safely far away, wrapped in a magnetic field and a thick atmosphere. Proxima b has no such luxury. It sits 20 times closer to its star than we do to ours. When Proxima Centauri erupts, that planet is standing directly in the blast. Not once, not rarely. Again and again, across billions of years. And this is where hope begins to fade. Can anything survive there? Studies suggest that repeated flaring could strip away a planet's protective ozone layer within just a few years. Once that shield is gone, ultraviolet radiation would hammer the surface with enough intensity to kill even hardy microorganisms. Some models suggest Proxima b may have lost an ocean's worth of water in the first 100 million years of its life, boiled away by its young, furious star. So is it dead? Scientists are careful here. They do not know. Some models suggest that if the planet held onto a thick enough atmosphere of carbon dioxide or nitrogen, that atmosphere alone might shield the surface. Liquid water could still survive, perhaps on the sunlit face, or in a warm band around its middle. Others suggest the atmosphere was torn away long ago, leaving nothing but bare, scorched rock. We do not yet know which story is true, and that uncertainty is not a failure. It is the frontier. But Proxima b is not alone out there. Barnard star. 4 tiny worlds. 6 light-years away lies Barnard star, the nearest single star to our Sun. For over a century, astronomers hunted for planets around it. And for over a century, they were wrong. In the 1960s, one astronomer announced a giant planet there. He defended the claim for decades. It turned out to be an error in his telescope. Tiny shifts in the instrument, caused by routine maintenance, had mimicked the signature of a world. He believed in that planet for the rest of his life. It was never there. The failure haunted planet hunting for generations. A warning about wanting something too badly. Others tried. In 2018, another planet was announced around Barnard star. 3 years later, it was refuted. The star became known among astronomers as a kind of white whale, always promising, never delivering. Then, in 2025, using extraordinarily precise instruments, astronomers finally succeeded. They confirmed 4 planets orbiting Barnard star. But they are strange. Each is smaller than Earth, only about 20 to 30% of our planet's mass. And they orbit so close that their years last only a few days. All 4 sit far too near their star for liquid water. They are almost certainly rocky, and almost certainly too hot for life as we know it. Still, they matter, because they prove something important. Even the small, quiet stars closest to us are surrounded by worlds. TRAPPIST-1. 7 Earths. Now travel a little farther, about 40 light-years. There you will find a dim red dwarf called TRAPPIST-1, and around it, 7 rocky planets, each roughly the size of Earth. It is the most Earth-sized worlds we have ever found orbiting a single star. 3 of them sit inside the habitable zone. The planets are packed so tightly together that if you stood on the surface of one, the neighbouring worlds would loom in the sky. Larger than our moon appears to us. Imagine that, a sky with other Earths hanging in it. But TRAPPIST-1 is a red dwarf too, and it carries the same problems. Tidal locking, flares, uncertain atmospheres. The Webb telescope has begun studying these worlds directly, searching for the faint signature of air. It does this by watching starlight pass through a planet's atmosphere as it crosses in front of its star. Different gases absorb different colors of light, so the atmosphere leaves a fingerprint in the spectrum. So far, Webb has found no definitive signs of atmospheres around the TRAPPIST-1 worlds it has studied. The innermost planets look especially unlikely to have thick atmospheres. The outer ones are still a question. The measurements are extraordinarily difficult. But think about what is happening here. For thousands of years, humans looked up and wondered whether other worlds existed. Now we are reading the air of planets 40 light years away. We are, for the first time in history, close enough to actually check. What would it take to go? So why not simply go and see? Here is the brutal truth about distance. Voyager 1, our fastest departing spacecraft, has been flying for nearly 50 years. At its speed, reaching Proxima b would take more than 70,000 years. 70,000 years ago, our ancestors had not yet painted a cave wall. That is the gap between us and the nearest world. There are ideas, sails pushed by lasers, tiny probes accelerated to a fraction of light speed. If they worked, a craft the size of a postage stamp might make the journey in 20 years, but it would fly past in an instant, a single blurred glimpse, then gone forever. We would wait a lifetime for a photograph. And still, scientists are working on it, because that photograph would be the most important image ever taken. Why these worlds matter? It is tempting to feel disappointed. The nearest planets are battered by radiation, locked in eternal day and night, possibly stripped bare. None of them is a second Earth. But consider what we have actually learned. We have discovered that planets are not rare. They are everywhere, around almost every star we look at. Even our quietest, dimmest neighbors have worlds circling them. And red dwarfs like Proxima and TRAPPIST-1 are the most common stars in the galaxy. If life can survive around them, despite the flares, despite the locked skies, then the universe may be crowded with it. Roughly 3/4 of the stars in the Milky Way are red dwarfs. If those worlds can hold life, then life may not be rare at all. It may be the normal state of the universe. But if life cannot survive there, then something else follows. Then worlds like ours, orbiting calm, steady, ordinary stars, may be far rarer and far more precious than we ever imagined. Then this planet is not one of many. It is something close to a miracle. Either answer changes everything, and the nearest worlds are the ones that will tell us. We have spent our whole existence on a single world. One warm, blue, sheltered planet, wrapped in air, guarded by a magnetic field, orbiting a star patient enough to let us grow. We thought that was ordinary. Then we looked at the worlds nearest to us, and we found scorched rock, locked hemispheres, and skies torn open by radiation. None of them are gentle. None of them are home. Right now, as you watch this, 4 light years away, a planet is turning slowly under a red and violent sun. It has mountains, perhaps, valleys, a horizon. Nobody has ever seen them. Nobody may ever see them. It may hold water. It may hold nothing at all. We do not know. They are the closest worlds we will ever find, and they are still impossibly far. Somewhere out there, one of them is waiting to tell us whether we are alone.